next is Anmol Krishan Sachdeva, aka Great DevOps, a senior hybrid cloud architect at Google, adjunct faculty at IIIT, and a renowned international tech speaker with 75 plus global talks. Let's give a warm welcome to Anmol Krishan Sachdeva. Welcome, sir. Welcome to CNCG Gurgaon.
Thanks a lot for inviting me. Just allow me a minute. I'll start sharing my screen. I'm arranging the screens.
Sure.
Okay.
Anmol will be speaking on modern platform dynamics with Crossplane managing infrastructure as data.
Okay. Very good afternoon, all present. My name is Anmol Krishan Sachdeva, and thanks for introducing me early, and also thanks for inviting me to the event. Today, we are going to talk about modern platform dynamics with Crossplane. Essentially, we are going to peel the layers of how exactly platform engineering can be done in an effective manner by using Kubernetes constructs and controllers. Specifically, we are going to get exposed to a construct named infrastructure as data. Many of you would have learned about infrastructure as code, but there are new paradigms getting introduced in the market. One is called infrastructure as data, and there are a couple of more new getting introduced. So we will explore them as well briefly during the talk. Just before I move further, this is a kind of word cloud, which is depicting the kind of experience that I hold. I have been pretty much active in the community, speaking at global conferences, even organizing some of like EuroPython, GeoPython, PyCon India, etc. You can follow me by scanning this particular QR code. Anyway, this particular slide deck is available on GitHub. I'll share the link to you after this particular call. So feel free to go ahead and check out the slide deck and the related repository. Just a disclaimer before we move further that the content presented during this particular session is something which is my own personal one. It should not be related to any organizations or professional bodies that I'm part of, and also some of the images I have used by ones which are generated by artificial intelligence. So such images should not be representing the information factually in a factually correct manner. So please ignore if at all there are any typos, etc., in the images, and don't treat them as legitimate one. Okay. So specifically, the agenda for this particular talk will be to understand what Crossplane is, what exactly it helps us achieve, how it compares with a bunch of competitors that are there, or the similar set of tools that are there in the space of infrastructure as code, how exactly infrastructure as code differs from the concept of infrastructure as data. We will then be getting exposed to understanding of the Crossplane components. We will get exposed to how exactly we can have new set of resources created via Crossplane and how we can manage infrastructure by using these custom resources. Ultimately, we will be having 1 to 2 demos depending on the time that we have. But anyway, the code that I'll be demonstrating is already there on GitHub. So you can, after the session, go ahead and check out the repository. There will be discussion about some of the key takeaways, some of the noteworthy points, etc., related to whatever we discuss as a recap. And then we will open it for questions and answers. So specifically, why exactly we require Crossplane? How does it fit in the CNCF landscape? How does it relate to Kubernetes? Whether or not it's a replacement for Kubernetes, or whether it's something which augments that. So all of that is something that we are going to explore during this particular session. So before we get into understanding what exactly IAC does, we need to understand how the IAC revolution came and how exactly configuration management tools got mature and how they started helping us with maintaining resources in cloud rather than just having the basic configuration management operations done. So late in 1990s, there were tools like CF Engine, etc., getting introduced. Even like if we date back to 1970s, there were a couple of tools which were getting used for having mainframes, data centers related configuration management handled. So essentially there was a requirement that we used to have virtual machines, or we used to have some servers. The configuration management for servers, if they grew in number, was getting very hard. That's where people thought that, okay, how much disk configuration should be supplied, what should be the configuration for the RAM, for the CPU, and for the different resources, or what all packages should be deployed on a particular machine, what all permissions or privileges should be there on a machine. People thought of building some utility or solutions for the same, and that's where uh, the introduction of tools like CF Engine happened. And Starting that, after having that particular revolution started, people got more mature. There were cloud providers that came in the market. So around 2006, there was introduction of AWS. Likewise, other competitors and vendors also came in the market. That's where there was a requirement to have even cloud related resources or public cloud based resources to be provisioned and configured via configuration management. And that's where tools like Chef, SaltStack, Ansible, etc. came into picture. This is where these tools essentially ruled the market for almost a decade, uh, until we had introduction of Kubernetes and containerization solutions happening in 2013-14 timeline. And that's where containers became popular. We used to understand uh, post that particular trend, that certainly there are kind of API first patterns which could be exercised. So rather than just configuring the resources, we could have APIs creating the resources for us in the cloud providers, not just limited to compute engine, but also data stores. We could have even some sort of new services like message queuing services, etc., or any kind of eventing services, etc. Uh, eventing related services, etc., kind of spawned using APIs. And that's where Terraform got introduced. So Terraform offered a declarative way by having HashiCorp language brought into picture, wherein one used to have HashiCorp language related configurations written. Basically, the providers used to provide a set of resources which one could use in raw manner, or they could iterate over them, or create some custom modules and bundle the resources to be able to have multiple resources deployed. And ultimately, once that particular trend settled down, people started to think that, okay, why is there a need to have HCL language specifically leverage for spawning the infrastructure? Why can't the regular SDKs of programming languages like Python, Golang, etc. help us with that? And that's where we got introduced to new platforms like Pulumi, wherein we can have programmatic languages used in form of SDKs to be able to spawn the infrastructure. So rather than having HCL language learned declaratively defining how things should be achieved, we rather follow the programmatic way. And that's where we get more error handling, conditional logic execution, and even kind of embedding the application logic within the infrastructure logic. And that's where Pulumi really got popular. All these tools which I'm talking about, Terraform, Pulumi, Ansible, Crossplane, have a lot of market adoption already. A lot of vendors have also got associated with them as providers. I have delivered a couple of talks in all these spaces in the past as well. You can check against my name on YouTube as well. Uh, but specifically, if we come to what Crossplane attempted to solve, so basically, people were seeing that this particular HashiCorp language and Pulumi, all the trends that were there for the infrastructure as code, were having some specific limitations, because these were focusing on having the platform administrators handle the infrastructure state rather than making it easy for the developers, the application developers, to be able to leverage the infrastructure or the platform APIs that they want to use. And we also saw a growing trend in people adopting more and more of Kubernetes based application deployment patterns. And that's where we saw even developers moving towards a Kubernetes based paradigm, wherein there was a very big surge in the number of organizations adapting containerized solutions and then hosting them on Kubernetes or some container orchestrator platform like Kubernetes, like Mesos, etc. And that's where Crossplane got introduced. And Crossplane specifically had a very unique touch to it, that it was acting like an operator from within the Kubernetes to be able to handle your infrastructure resources. So whole of this talk is going to focus on Crossplane, but we are not really settling down on this particular aspect. Specifically, there is a new paradigm which has got introduced, which is called infrastructure from code. Again, like you would see a bunch of talks against my name if you just search about them. So I delivered one in the Linux Foundation Open Source Summit in North America last year as well. So Nitric is an infrastructure from code pattern wherein you really don't need to write any definitions for infrastructure. Rather, whatever application code you write based on some decorators or SDK related invocations, you have the underlying infrastructure first getting inferred wherein if you are writing a code which requires some message queuing system, it would get inferred that okay, message queuing is required. It will first go ahead and in the required provider or the cloud platform deploy the message queuing system. Likewise, if there are any other platform dependencies, it will deploy that, and after that it will deploy the application. So that's where more of serverless workloads and event driven architectures can be met easily without having any dedicated let's say effort given to how the platform management can be done. And if at all you don't really want to have your developers get exposed to any of the platform related intricacies or dependencies, you can have some golden templates or governance templates created, and you can expose those resources in form of nitric modules, pulumi modules, crossplane modules, terraform modules to the developer ecosystem, so that they can have a self-service way of deploying the resources without having to understand much about how HCL works, how Kubernetes works, how Pulumi works, how the underlying Nitric platform related invocations happen for contracting with the providers, etc. So this is in nutshell what we are looking at from an evolution perspective, and today's discussion point will be around Crossplane. So many of you would question, I already know Terraform. Why exactly do I need another tool for managing infrastructure as code? So the very first impression that you get after getting exposed to a tool like Crossplane is that Terraform is a command line utility. It helps you interact with some of the control planes that are getting provided by the cloud providers. Like Terraform is able to talk with AWS management APIs or GCP management APIs like Google APIs.com to be able to spawn new resources or provision them or maintain them. But Crossplane essentially comes with a different aspect itself, wherein you no longer have to rely on a command line tool to be able to interface with any cloud provider. Rather, you have your developers interface with Kubernetes, wherein Kubernetes acts like a universal control plane for any of the resources that you want to deploy in any of the cloud providers. Okay, that's where Crossplane becomes that intermediary party which coordinates with the cloud providers rather than you going ahead and having some scripts written that directly interface with the cloud provider. So that's where there is a very big difference in the way these two tools operate. One is essentially running as a command line tool, one is running as a control plane. Okay. The second thing is with Terraform, you would have seen that generally, if at all you have, let's say, deployed any particular resource, let's say an S3 bucket or some virtual machine, and someone has gone ahead and manually changed from the console, from AWS console or GCP console, let's say, the state of the virtual machine, or has added some configurations or has added some IAM role based access control related bindings on the resource, then in that case, Terraform really is unaware of those changes unless you run a Terraform plan again, or you force a Terraform state refresh. And then in the next apply, it actually gets caught. And it could be that there could have been some breaking changes introduced, or there could have been some unintended changes introduced, or probably you ended up in a production outage sometime wherein you had to go and manually do some kind of rectifications or mitigations on the resources, and then post recovery you forgot to have the changes replicated in Terraform, and that's where now the state that is there in Terraform is deviating from the state that is there in your cloud provider. So that means there is some drift that has been introduced between the state that you are managing and the state that you have in the cloud provider. So that's where like a very big chunk of day two operations come into picture. That's a very important point wherein Crossplane really excels. The other thing is coming to Terraform again, we understand that the state files are what essentially help us maintain the Terraform related state. It could be depending on how maturely you have handled the Terraform resource creation or module creation or bundling or coupling of modules and resources, the size of state looks like, and the resources that are packed in the state file. But generally, the state files are intentionally kept as monolithic so that you can have the dependency injection with explicitly depends on conditions, etc., and the Terraform resources taken into consideration. If at all any context needs to be passed, rather than having, let's say, data sources leverage in the Terraform modules, many people prefer going by referencing the module related outputs because they think it's easy and they save on some lookups. So it's about how maturely one handles the Terraform modules. But generally, for larger organizations as well, it's pretty much about everyone kind of aiming to simplify how they can manage the Terraform state and the corresponding modules. And intentionally, unintentionally, people end up having monolithic state files created for Terraform. So that's where a lot of tight coupling gets introduced, and it becomes very difficult again from a day two operations perspective, when we have to modify any resources, when we have to transfer the state, when we have to go ahead and let's say import any resources. Also, you would be aware of one limitation of Terraform, wherein if at all you want to have Terraform resource imports done, resource imports are only supported in raw manner, which means if at all you created Terraform resource uh, using a proper raw resource, then you would be able to have an apples to apple comparison between the newly imported resource that you have, because the resources that are getting created by modules in the original state, they would be coupled with the module and bound to the module context, but in the imported state they would just reflect raw resources. So essentially importing a whole together module is not possible in Terraform, and that's where another issue comes from day two operations perspective, wherein a lot of people keep on migrating their organizations or related resources or estate on the cloud, and that's where importing of modules become tricky, because individual resources can only be imported, not the complete modules. Okay, when I say not complete modules, it's like we cannot have a module specific import done. We will need to have all the resources taken individually and imported, and they cannot be again bundled back into module unless we have a recreation of the resources taken. Okay, and then there is a lack of self-service for developers. So basically developers always whenever they are dealing with Terraform, feel this burden of learning HCL language, and they also understand that it's not just about them knowing about some TF variables, rather it's about them understanding how exactly things need to fit into the modules, or any of the attributes that are there which are relevant, or how to handle conditionals if at all there are any iterators or counters, etc. So again, from another perspective of developers consuming your golden modules, it's not very straightforward. Then another thing which is pretty obvious is that from principle of least privilege perspective, it is generally suggested to have individual cloud specific resource permissions provided, or IAM role bindings created for the users who would be going ahead and deploying the resources or maintaining the resources, be it manually, be it via Terraform or some automation tool. And that's where if at all you have an S3 bucket, if you have, let's say, some RDS instance, you will need different set of permissions, because you are directly interfacing with the cloud provider, right? So you don't have any intermediary who can essentially on your behalf take the control of negotiating with the cloud provider for the API exchanges, etc. And also Terraform is just a CLI. There are no contracts as such. How you maintain the Terraform module specific version or resource specific versions is just barely with the version control, depending on that particular version control system. If at all you are not using any branching strategy, or if you are not using any uh, let's say release tag strategy, then it becomes very difficult for handling the promotion of modules from different SDLC perspective as well. So if you have, let's say, Terraform modules deployed in dev and you want to promote them to higher environments like staging, UAT, horizontal QA, or production, then in case you are not maintaining branches or release tags, or you are not having proper promotion process lined down with from a version control perspective, it will be very difficult for you to have the promotion done. And many people make mistakes wherein they end up mixing the state files of production and development as well, depending on what utilities they are using. Some people use Terraform workspaces and they mess up in that space. Some people use TerraGrunt, still they mess up. So it's very convoluted. There is no clean way of having API contracts maintained for any of the resources that you are deploying. So with this, we understand now that there are already many challenges with the current ISE approach, if at all we are just going with Terraform. So that's where we get introduced to a tool named Crossplane. It's essentially an open source framework. Recently, this particular project has got into CNCF incubating phase, and also there is an active community over Slack. However, the community is not as strong as we have for Terraform, and I would say even Pulumi one probably is running shoulder to shoulder with Crossplane. The thing is that it's not exactly uh, a replacement for Kubernetes. It is more of a Kubernetes extension. So it augments the functionalities of Kubernetes. Instead of having the raw native resources of Kubernetes, which are getting offered by the native API groups like pods, deployments, etc. Instead of these resources, we can have custom resource definitions, very much like a Kubernetes operator or controller pattern, like you would have built using Kube Builder, etc. If at all you have been exposed to. So this is where this particular open source framework helps you extend your Kubernetes capabilities to be able to manage resources not just in one cloud but in multiple clouds. It doesn't really need to be a public cloud provider as well. You can have even resources on VMware or any other providers, whosoever has some API exposed, and that particular API is consumable over some network calls, right? So that's where you can even have non-Kubernetes specific resources spawned up, very much like how you spawn them using Terraform. And you can have support for multiple providers, be it cloud providers that are operating in public capacity or even private capacity. And the best part is that you can bundle the resources in a manner wherein they appear to you like a single API. What that means is whenever you have Kubernetes pods or deployments dealt with, you see that there is an API version like V1 beta 1, V1 alpha 1, V1, etc., like config map V1 or deployments V1 beta 1, etc. So that's where you have a specific API group which has a particular API resource, and that has an API version. So this is where, when I say single API, I am referencing to that kind of a Kubernetes resource, which in our case is a custom resource. Okay. Crossplane also offers built-in reconciliation logic, which means the controller or the brain, which is essentially sitting and orchestrating the deployment of the resources, checking whether the resources have really got synced with the cloud provider or not, whether any anomalies or any issues have been detected in the outside provider, and based on that, whether we are able to reconcile the state or have the drift detection mitigated, etc. All those things are possible with Crossplane. You can even influence that particular behavior by specifying your custom logic for how you should be reacting, how the controller should be reacting when a specific state is achieved. When you do kubectl describe pods or describe deployments, you see some status and conditions and reasons. You can actually act upon the statuses, the conditions, the reasons essentially in Crossplane, and you can define what should be the behavior of the resource from a controller perspective. If at all multiple resources are getting managed, then how those resources have to orchestrate, whether at all any deconstructor logic has to be written, etc. Like all of that particular flow is something which is pretty much easy to be streamlined using Crossplane. And hence, it actually gets referenced as a universal control plane, because now we are using JSON or YAML files like we supply for the Kubernetes manifest. Very much like that only, we are supplying the Kubernetes manifest for managing our custom resources. And this is where you are able to have multiple platforms providers dealt with, and hence it's Kubernetes which becomes the universal control plane or the brain for managing the resource lifecycle for all the resources that you have. And essentially, if you just kind of think about it, you can have some platform specific abstractions also introduced. Like you can have a module which packages the IAM for your RDS, along with some specific SSH access and firewalling related stuff, and also configuration of the RDS, that you would always have the storage, let's say, vertical scaling or capacity sizing related decisions taken by Crossplane in a deterministic manner, wherein you can say, if at all like we are hitting 90% of storage on our RDS, we will be able to have it bumped by another 50 gigs whenever 90 is getting hit. So that's where it can be a deterministic platform control that you can enforce. Likewise, you can introduce different classes of objects and different versions of Kubernetes objects for different use cases. Like for the people who want to go ahead and try out some LLMs or AI models, etc., they can have some GPU specific virtual machine classes introduced, and they can be referenced as Kubernetes resources. So whenever you have that particular let's say resource getting leveraged, like a Kubernetes pod spec, you have Kubernetes resource spec for that GPU related instance. You have some standardization baked in, wherein the size, the compliance policies, security hardening related requirements, firewalls, etc., and what Purpose was mentioning, like any kind of seccomp profiling, whatever you have to do from security hardening perspective, that can be dealt with. So thanks, Tapas, for taking that particular section. I think people will be able to relate it easily with that particular thing. Uh, so this is where platform abstractions can be introduced, so that for the developers, it is very easy to go ahead and specify the YAML and not be bothered about how the orchestration or exchange of context, etc., between the resources is happening. And there are custom APIs, as I am mentioning, because everything that we are talking about from a custom resource definition perspective gets registered in a custom resource definition, which is powered by Open API specification. So we will see that in the demo. And ultimately, you are able to have declaratively whole of your infrastructure managed via data. Also, the best part is, if at all your Kubernetes cluster has some issue with respect to control plane seeing any outage, etc., if at all you are using any backup restore solutions or snapshotting solutions, your etcd data will be getting backed up, and the state of your infrastructure is actually there in your etcd data. So that's where, even if there is any kind of disruption happening, or some operation has happened in the cluster because of which the control plane is not responding, your resources in the cloud would still be intact. And as and when you have the recovery done, again the reconciliation loop will start, because we are picking from the point where the etcd stored the last state for this particular object, right? So this is where it is all getting tracked via data, rather than spending time on having Terraform refresh done or plan related issues addressed, etc. And the best part is that a lot of providers are investing in creating modules, and for whichever providers we don't have modules ready or the resources ready, there are a couple of workarounds for them as well, to be able to get unblocked in a self-service fashion again. So we are going to discuss about this after we are done with our demonstration. So in nutshell, if we have to describe what Crossplane is helping you with, if you just take a user who is interacting with Kubernetes, Crossplane is sitting on this particular Kubernetes cluster, and it has association with the providers. It has the right authentication schemes and the provider configurations mentioned in the provider templates only, so that they can authenticate with GCP, authenticate with any of the other providers. Even Terraform you see as a provider on Crossplane. We will talk about where that exactly fits. And essentially, Crossplane is able to have itself treated as a universal control plane, basically because of the controller that is residing, and it's able to enjoy all the benefits that Kubernetes is able to enjoy. So that means, if at all you have multiple tenants within your organization, when I say tenants, these could be different, let's say stakeholders, sister organizations, probably some merger acquisitions could have happened in your organization, because of which you have onboarded a new team, or it could be like separate set of development teams who want to manage their infrastructure separately and independently. So that's where Kubernetes namespace isolation is something which can be exercised as well, to imagine the tenancy. So all the RBAC related stuff, all the tenancy related stuff is pretty much seamless, and you have advanced topics as well, wherein you can pretty much have orphaning of resources done, you can have reparenting of resources done, you can have leasing, etc. So all those are advanced concepts which probably we won't get to discuss time to discuss about today. But again, like, feel free to reach out to me, or like next month I'll be there in KubeCon Japan presenting at OpenSSF. So feel free to connect if you are around that. So there are a bunch of Crossplane components which we need to be aware of before we get into the hands-on. So there are these terms which often you would be getting exposed to, and these are some of the abbreviations or shorthands which people generally use. It's probably a bit difficult to wrap your head around just at the first glance with the shorthands or the abbreviations, because they seem to be pretty similar. But the I would say analogous abbreviation context that is there is with the custom resource definition related suit. So instead of treating X as custom, imagine instead of XR here, CR would have been written. Then in that case, CR would stand for custom resource. Here, instead of C, we have X. X stands for composite. So instead of custom resources, now we have composite resources. Instead of custom resource definitions, we have composition resource definitions, composite resource definitions, right? So that's where it's very easy to use that analogy and go about understanding this. But again, we really don't need to set on the terminologies. You have adequate documentation for Crossplane, which you can go through after this session. Provider is something which is like the provider of services. It could be a public provider like GCP, or it could be a private provider like VMware. Again, VMware could have public offerings as well, so I'm not really commenting on the capabilities here, so please be cautious that it's just an example or hypothetical kind of scenario that I'm positioning, and not really commenting on the capabilities. Okay. Provider config related stuff is something wherein you specify how to authenticate with the provider, because it's not that you will be able to directly interface with GCP. You would need something like a service account. You would need some sort of credentials like a username, password. You would need some sort of keys to be able to access the GCP services or AWS services, like you have via IAM and service account or robotic account keys. That is where the provider config comes into picture, wherein you suggest how you will be able to interact with the upstream provider. This is pretty similar to how you have the provider.tf in Terraform, wherein if at all any custom endpoints or jurisdictional or region specific endpoints are to be used. So instead of, let's say, cloudplatform.googleaps.com, you want to use eu-cloudplatform.googleapi.com, because you are trying to access resources on Google Cloud Platform which are not global but which are specific to a specific region or jurisdiction. You are using EU- as the prefix or US- as the prefix. Like you would see customers who are using GDPR related compliance constructs to be using jurisdictional resources rather than global resources. So this is where like provider config can help us override the endpoint for the API that we need to reach. It can help us specify the authentication mechanism. Again, coming back to the zero trust related topic which Tapas was talking about. From a service account perspective, it is something which is not really considered as secure, because it requires you to manage keys and JSON files which have the context and the authentication information. Rather, there is a concept which you should all go and check, which is called workload identity federation, which allows you with keyless authentication. So that's again something in your zero trust tool stack that you should be exploring on top of the topics that Tapas mentioned about, just to interact with any of the cloud providers. So here you have option to go ahead and set up Crossplane using zero trust principles, like using workload identity federation on hardening of any of the resources, etc., or even hardening it in manner as to using some specifics of the provider APIs. Managed resources are the actual resources which get deployed on the cloud provider. So assume it to be something like AWS S3 or RDS or GCS buckets or Cloud Run or Kubernetes cluster itself, like a GKE cluster or EKS cluster, etc. Composition is nothing but a composition of managed resources. So it's like bundling multiple resources into one specification or template, so that you can go ahead and have that as a bundled deployment. So that's where managed resources can be treated analogous to the Terraform resources, the raw resources that are available from the providers. Composition can be treated as a module, and then composite resource is essentially the implementation of that particular module in Terraform. Like you create a module and then you use source equal to module or reference some remote repository, and then extend it by supplying the attributes and the variables that you want to leverage for your own implementation. So this is very similar. So we have composite resource, or the XR, getting treated as the implementation of the module. But the good thing is that this particular XR is something which, by the nature of its design, is a cluster wide resource. But if we want to go in a multi-tenant manner, we can use claims. So claims are namespaced XRs, you can imagine them as. So that's where if you want to deploy a S3 bucket, an S3 bucket, which is to be used by all the teams, you can deploy that as an XR. If you want to deploy a team-specific bucket, then you can go ahead and deploy using the claims or XC. Okay, so that's where you have good control of exercising multi-tenancy and also deploying shared resources via Crossplane. So now that we have got a good context over how these things are working, ultimately the idea that is coming is it's all about the developer experience. It's all about the platform engineering. It's all about the constructs that we uh, exercise from a site reliability perspective, DevOps perspective, DORA perspective, whichever pillar you may want to put it under. But ultimately, development experience is something which needs to be enhanced, and you need to have some sort of common ground wherein you can introduce your standards, enforce compliance, enforce any kind of security related, let's say, controls or access control measures, or even I would say if you are building, if you are mature in your development journey, you would aim for something called as center of excellence. So the center of excellence, or the technical center of excellence from a platform engineering perspective, is something that you can achieve if you follow the principles in the right manner. I'm not really talking about it is only possible via Crossplane. Probably it could be difficult to achieve it via Crossplane at the first go if you are not really that much into Kubernetes controller pattern, but it can be done with other tools like Terraform, Pulumi, and others as well. Okay, so that's the kind of biggest kind of takeaway, that whenever you are talking from a platform engineering perspective, we really need to see how exactly the self-service experience for developers look like, and how exactly the resources are getting created, and whether those resources are consumable by the developers in the right manner, whether we are able to adhere to the standards that are there, defined by the organization or defined by any center of excellence team. So now there is this particular repository which I'm going to expose you to. So it's time for hands-on. I have already created a tiny URL. I'll paste the link of that as well along with the GitHub repository. So tiny URL is just this particular link, .com, and the endpoint is same basically. So this is the GitHub repository that you can go through. But as of now, I'm going to switch to my local terminal. So you can follow along, or you can check the recording afterwards as to how we go. I'm going to use not a provider provided Kubernetes cluster, but rather a Minikube cluster. You could go with K3s, kind, any local cluster as well, if at all you want to follow along and you have a GCP ecosystem, because I'll be deploying the resources in GCP. As of now, I have not really got any cluster, so I'm going to have a Minikube cluster started. So first, for starting Minikube cluster, for the people who are new to Minikube, again, like this will be a primer on Minikube as well. Minikube essentially offers you a bunch of drivers. By default, the driver that is there is a Docker-based driver, but you can use QEMU, or you can use any other virtualization provider as well to help you with the advanced features if you want for the containers. Like there are a bunch of custom resources which will not work with the native Minikube default Docker driver. You would need, let's say, if you want to have hyper virtualization related features. For example, you want to manage virtual machine deployment using Kubernetes, using KubeVirt, let's say, you would need some sort of virtualization features additionally on the underlying host as well. And then you will need to modify the Minikube related configuration, the bootstrap configuration. As of now, I have got Minikube kind of seemingly up. So I'll do Minikube status. This will show me whether my cluster is up and running. And I'll also do kubectl get nodes. As of now, I have created just a single node cluster. So this is my Kubernetes cluster node, which is currently running, on top of which we will be deploying the Crossplane specific providers for GCP. And then we will try to create some resources. We will have 2 demos, and we will accordingly see how far we are able to get. So in the repository, there are some additional files that you see here, which are in green, which are not pushed because these are like containing some secret content, etc., that I did not want to put. So the YAML files that you have in the GitHub repository are having a suffix of .ref. So you, whenever are trying these samples, should be removing the .ref suffix. So if I go here, like this .ref should be removed, this .ref should be removed. Likewise, in composition demo, the .ref should be removed. And if anyone wants to see the slide deck is also present here. So again, like after the session, you can reference these resources. Coming back to this particular thing, so in order to deploy Crossplane, we require Helm chart to be used. So I actually have added a Helm chart repository. This is essentially referencing the Helm chart that is there for Crossplane, available in the public registry for Helm. And I'll answer your questions towards the end, basically. So yeah. Okay, so we essentially have referenced the upstream repository. We just need to make sure that we are having the repository up to date, so that we are pointing to the latest version of the chart that is available. There is a big command for which already behind the scenes I'm having a playbook, so I'll just copy that. So we are doing Helm install. Helm, for the people who don't know, is like an orchestrator and package manager for Kubernetes. When I say package manager, you can have a bundle of manifests which can have some templatization utilized to be able to have reuse of some specific values that you want to feed to your Kubernetes YAMLs or manifests. So assume that you want to have your Kubernetes label applied to your pod, your service. Then in that case, you can have a common service. Let's say you can have a common label defined in a YAML file, let's say overrides.yaml file, that will be treated as a value which can be passed to the Helm chart. Helm chart is essentially composition of the raw templates which have some placeholders where the values that we are supplying using overrides or values.yaml can be substituted. So assume that label to be getting injected into your pod and the service at the right place wherever the placeholders have been defined in the template. It works on the Go template engine behind the scenes. So anyone who has worked on Go templating would be able to relate to it. But for now, again, like this particular session is not on Helm, so I'm just not getting too much deep into it. As of now, what we are doing is we have pulled the Helm chart from remote. We are referencing that particular remote chart here. We are trying to install that chart and naming that chart as Crossplane. We are doing a dry run just like a kubectl dry run that one does, and we are having it as part of a namespace called Crossplane system namespace. If at all the Kubernetes namespace doesn't exist, it will create a namespace on its own. So if I do kubectl get ns, as of now there is no namespace called Crossplane system. But if I go ahead and have this particular chart command run after the dry run, basically it will go ahead and create a Kubernetes namespace. So you can see the output of the chart. It is going to create a bunch of resources for Crossplane, whichever have been specified in the template in the upstream. So there are a lot of resources. Again, we don't really need to get into exactly how the resources are positioned or placed or created as of now, but exactly what we need to do now is to run the Helm chart deployment for this particular Crossplane release, and we want to see what all resources are there. So if we now do kubectl get ns, it just created 5 seconds ago the Crossplane system namespace. And if I go ahead and I check the resources that are there in the Kubernetes Crossplane system namespace, then in that case, if I just do a get pods, it has deployed some controllers from Crossplane. At this time, there are a bunch of CRDs also that should have got added to the cluster. So now you see a lot of API versions available which have crossplane.io/v1, beta 1, v1, etc. These are some of the native resources that we will be using, but on top of that we will be having provider specific custom resource definitions also deployed. So next thing which comes is the provider.yaml file itself. So here if we go provider.yaml, it is referencing some public provider that is available for GCP storage so that we can create some GCS buckets. It is referencing some public provider for Google Cloud Platform so that we can exercise the Google Cloud Platform related common operations. And there is a GCP compute so that we can create some compute network, compute virtual machine, etc. How you really need to navigate to the marketplace is that there is a URL marketplace.upbound.com where you can go. You can start searching for the list of providers, and there is an advanced concept called composition function. Again, we are not going to get into composition function or configurations today. Our focus will just be providers, but I'll just give you a glimpse of how the composition works. The providers are, again, like a plethora of providers are there. You can go through this particular list. There are community providers, partner provided providers, as well, and official providers. As of now, our intent is to go with official providers, and we have GCP specific providers appearing here. Rather than going with specific providers that are listed here, I'll just show you that just doing a simple search here will also give you a directory of or catalog of the providers that are individually available. So what I did for, let's say, compute, I went ahead and had the GCP compute related provider checked, and I just click on install package manifest. This is what is giving me the provider related code that I showed in the provider.yaml file. So this is where if I go ahead in my configuration, the GCP compute related provider is available. So that's how you have to navigate from the documentation to your local development. Once you do this, you can apply the provider.yaml file. So what we will do is I'll get into the right directory. I'll have provider.yaml, which is this particular file applied. So we will do kubectl apply -f provider. Now, since we have applied the provider, we need to actually watch how the provider is responding. So that's where there will be two statuses that will be getting shown. One will be the installed status, one will be the healthy status. And there is going to be an auto injection of the global provider, which helps setting up the, I would say, provider specific authentication and endpoint related configurations. So that's where this particular provider is an auto injected one. Wherever you are calling any GCP provider, this will get auto injected if it doesn't exist, and it will match the version that you have in the resource supplied. Now this particular provider got true, which means it has become healthy. The next provider that got healthy is compute. So you see that reconciliation is happening. It is actually waiting behind the scenes to see whether I have been able to have the provider related configuration established or not. And that's where if we go ahead and I'll open a different tab, I'll just go ahead and do kubectl describe provider, and I'll give the provider name as cloud platform. If I just go ahead and see what exactly the output of it is telling me that it has been able to pull this particular provider, and it's a container image or artifact, which means one thing which is very different from Terraform is that in Terraform you use the sources. Those can be local sources or references to Git repositories which have some modules getting hosted. In Crossplane, you rather rely on some artifact registry which manages the provider specific images. These are essentially container repositories only. XPKG Upbound is the Upbound specific public repository where the artifacts are getting stored. And that's where like you are having this particular package first requested to be deployed. Then it checks that its health check is failing. Then it tries to reconcile here, and then it tells us that the package provider has got successfully loaded. Okay. So now we have all the packages that we require essentially introduced. So next thing is to go ahead and check the provider config. So before we have provider config checked, so provider config reference I'll open because again this one is a secret one. So here what we are doing is we are referencing a Kubernetes secret which resides in the Kubernetes Crossplane system namespace. The name of the Kubernetes secret is GCP secret, and it has a key in its data which is named creds. Now, what this key entails is the actual service account or the programmatic account through which we should be able to access the GCP resources using an authentication method, right? So that's where, as of now, what I have done is I have got a service account of mine, which looks very similar to this particular service account, but this has placeholders. So this is how a GCP service account looks like. This has authentication information, client email, private key, etc., through which it is able to interact with the GCP APIs. So I have mine placed somewhere in the upper directory. I think I'll need to do a double thing. And yeah, so what we can do is we can go ahead and deploy our secret using this particular command, and then we can see whether our secret has got deployed, and our secret now has a creds field. So that's where we can reference that in the provider config reference that, okay, in the Crossplane system namespace, there exists a GCP secret which has the creds as the data field, and we are taking the content of this creds, which is nothing but this particular JSON file, through which we are able to establish connectivity with the Google APIs. Okay, so once this is done, we essentially go ahead and deploy our provider config as well. Again, I'm going to supply the actual provider config, which is referencing this particular thing. And then we can do kubectl get provider config, and it will show us that GCP provider config got established 8 seconds back. Then what we are going to do is we are going to create a storage bucket. Here the sample is, so this is like a GCS storage bucket. I'm going to have it created in a specific project, which is having the ID. This is some random ID that I created. I'll be naming the bucket. You see, as of now, there is no bucket with this particular name in the prefix. I'll be naming the bucket here specifically with that particular name, and then I'll be supplying the project ID of this particular project so that I can have this particular new GCS bucket deployed in this particular project. So I already have a file created with a storage bucket.yaml, which has this information. I'll just name the bucket as 02 for now, and I'll go ahead and I'll apply this particular storage bucket.yaml. Now what it will do is it will start creating a bucket resource behind the scenes, which will be using specifically the storage bucket provider that we saw in provider.yaml. So as of now, you see it's synced and ready, showing no status, but soon it will start showing the status as true, false, true, unknown, etc., because the reconciliation loop will be working in background. So here is the provider that we leveraged. I'll open a parallel kind of terminal so that we are able to inspect what is happening behind the scenes. So we will describe the bucket, and this is the bucket name. And I'll do a trick here. I'll do a watch on the describe output as well, so that we can monitor that describe output. But because the describe outputs are generally long, I'll have another technique used of tailing or cutting the output of describe. So as of now, it has established the project ID here. It has got the reference, but it has not really started to negotiate the creation. So now it has started the creation, and that's where you are getting the Kubernetes events as well. So that means you are even getting observability solved. There are Prometheus metrics as well for Crossplane that you can enable, through which you can get the metrics specific to whether or not a provider is working, whether or not a resource has scheduled any resources, etc., getting captured in form of Prometheus metrics. So you see that this particular resource now has got true and true, which means now if I go to GCP, and as per this particular event, I see that successfully I have requested the resource creation as well. If I now go to GCP and I do a refresh, I should be seeing this particular bucket. So here is my bucket. So that's where I'm able to create the resources, and even I'm able to manage their lifecycle. If I just go ahead and have kubectl delete -f storage bucket done, you will see that it will go from here, and also it will trigger a deprovisioning operation at the GCP side. So this bucket has gone. So instead of doing now Terraform plan, apply, Terraform destroy, etc., we can manage all the things via Kubernetes only. And that's where we are getting rich events as well as part of our Kubernetes operator, so that if at any point of time, even after we have deployed something during the night, something goes wrong, we can get an alert using PagerDuty or whatever alert manager you have. And we are able to go ahead and fix the issues if at all we need to. Else, Crossplane is sufficient enough to be able to reconcile the state and get the resources back to working. Okay, so that's the first demo that I wanted to show. The second demo essentially is around a composition a pattern. So this is where we will be creating a GCP project. We have a composition demo folder. Here we have supplied an XRD. XRD is nothing but the composite resource definition, like you have the custom resource definition. And it tells that I am expecting two fields in my resource to be supplied. One is the name field, one is the VPC network field. And I am telling this is an open API specification specifically that I have supplied. So I'm expecting, like in the spec section of the pod, you supply container image, name, args, etc. I am expecting name to be present, which is of string type, VPC network name to be present, which is of string type, and it could have been any other thing as well. Like you could have gone ahead with an array or an object of array or array of array, any nested object you could have gone with. I'm just choosing the string type for simplicity purposes. Then we have something called as a composition YAML reference. This is nothing but a composition kind, which is a template for managing our managed resources. So I'm using a managed resource of kind project, which is coming from the cloud platform GCP provider. I'm supplying a spec, which is a dummy spec, which will be overwritten with the values that we supply in the actual XR, which is this particular reference we will come shortly to. So imagine this to be like a deployment related configuration, and xr.yaml to be the specification that you want to supply in your deployment specific configuration. So this is essentially your code wherein the controller will be checking on the XRD and this particular composition to see whether you are validating whether your schema validates with the spec provided, etc., or not. So this is where I'm providing some project name, project ID. I'm telling not to create any VPC network. I'm telling it which billing ID to associate it from GCP perspective. I'm supplying the folder ID, etc. And then I'm enabling some APIs as well. So I'm not just talking about one resource. Now I'm talking about creating a project, enabling APIs, and creating a VPC. So I'm enabling two APIs. One is Google Compute API. One is the service networking Google API, and then I'm creating a VPC network as well. I'm also telling if at all any default network gets created, which by default gets created whenever you have a GCP project getting provisioned, if at all you have not opted for, to be deleted or deprovisioned. So that's where we are providing this. Now with the resources, essentially we are providing a provider config reference as well, so that these resources, whenever are getting deployed and are interacting with the Google APIs, can authenticate using the service account that we fed in our provider config.yaml or the GCP secret one that we created. And then finally, we have xr yaml.ref, which is like your actual TF vars, wherein you are supplying the variables, the corresponding thing. Now you see X project is the kind that I have created. So this is a new custom resource that has been created. But this X project is coming from where? It's coming from the xrd.yaml. So you could reference it as X project. You can reference it as plural X projects. And if at all you want to go namespace wide, then you will need to change the kind to X project claim. Generally, this is a good practice to have claim related resources differentiated from the XR related resources for conciseness and clarity purposes. So what we are going to do is we are first going to go ahead and apply the composition. So this is where we are going to have the CRD deployed. So now if we go ahead and do kubectl get CRD, we will see that we already have X project claims and X projects both provisioned from the xrd.yaml. Then what we can do additionally is we can even check if the API resources are there. So we have just triggered the command kubectl API resources, and I'm doing a grep. You have a kind present as X project, and you have a kind present as X project claim. Then what we can do is we can deploy the composition. So the order is you first apply XRD, then you apply composition, then you apply the XR. If at all you are using composition functions, then the order changes a bit. You have to apply the function beforehand after the XRD. So this is where I'm applying the composition. Now composition has also gone, and now I'm ready for having my actual resource deployed. For the resource deployment, I just want to make sure that this particular demo kind of creates a unique project. So as of now, I'm going to create a project which has this particular ID, and it is going to have a VPC named Summer Native Cube. What I'm going to do is I'm going to just go ahead and apply the xr.yaml file. So this has been applied. Now I can go ahead and watch for what exactly is there as part of composition. Now earlier we were doing kubectl get resource like get bucket, etc. Crossplane rather has a command which is called crossplane beta trace. Here you can supply the newly created compositions reference only. So instead of 101, I'll supply 121 that was supplied here. So here we will see that whatever resources are there as part of this particular composition are getting essentially tracked, and it is attempting to reconcile. So some of the resources are failing because there are dependencies. The network cannot be deployed before the project gets deployed. So if it were to be in Terraform, let's assume you were trying to deploy a network before a project existed, Terraform would have failed in the apply, telling that project doesn't exist. But here what is happening is it is reconciling behind the scenes. So till the time project comes, it is reconciling, and as and when the project will come, it will automatically create the network. So it is doing all the reconciliation checks. It is also resolving the dependencies on its own without us having to define explicitly using depends on like we do in Terraform. So that's where it is interacting with the Google management APIs or the provider specific management APIs and is able to reconcile the stuff. So now it has already created the project service. It is still bootstrapping the project. Probably some operations are there, but in a couple of seconds, we should see that all of these resources will become ready. And it will become true synced and true ready. True ready means the resource has been deployed and it is already working in proper manner at the cloud provider side. Synced means that it is synced from a drift detection perspective or not. Okay, whether the state that you have defined in data within Kubernetes is matching the state that is there on provider. If at all anyone goes ahead and changes your resource directly in the cloud provider, this will for some time get to false unless until the next reconciler logic kicks in after 30 seconds or 60 seconds, whatever is the period defined by your provider, and then it will sync again to true, and the resource will get ready. So this is where we are just waiting for this particular network now to get created. Already we have the project services enabled. By now we should also have a project created. So I'll go ahead and I'll try to see whether my project has got created or not. So this is where I'll go and I'll check if the project exists. Yeah, the project exists. So this has been created via Crossplane. Now we can go ahead and see that, okay, the network also exists. So there should be a network. If we go to VPC networks, there should be a network named Summer Native Cube. So here we have default network and Summer Native Cube, but we we suggested it to not go ahead, we guided it to not go ahead with any default network and remove that. So that's where now we should be seeing in a couple of minutes the default network will also go away as and when the project gets to a ready state, because it is still kind of doing some sort of operations behind the scenes. That's why the resource has not got ready. Once the resource gets ready true, it will automatically delete this particular thing, because we have instructed it to have the auto creation of the network removed. So with this, like once it gets true, I'll have the demo wrapped up, and then we will come to the takeaways. So you will have to allow me 5 more minutes. I know I'm extending a bit, but if you can bear with me, it would be helpful. You will get to learn about some of the trade-offs that you have to consider, because it's not just happy path that you have to be aware of. There have to be some issues also that you have to be aware of. So now you see the default has gone. So now with this, the demo concludes. So let me switch back to my slide content again. So there are some noteworthy points. First thing is having naming conventions. We actually ended up having a lot of resources created in the composition, but we were actually repeating the kind of resource templates. Like we could have gone ahead with some sort of templating engine here itself. So instead of having this particular block repeat for compute API and service networking API, because both are exactly the same specs that we need to provide, just the name of the service needs to change. Instead of service networking getting supplied here, you will be having compute API applied here, or you want to make it reusable so that any new APIs that you want to enable in your project can be fed in via some sort of array. So that's where there is a function that is available, which is a function Go templating, which allows you to have templatization done very much via the Go template engine. You first will need to introduce a Go template inline module, and then you can specify for a bucket a for loop here, wherein it gets the value from the xr.yaml, does a for loop on the resources, and then if you have opted for creating 5 resources, it will go ahead and create 5 resources instead of you copying that individual block again and again. So instead of copying this block again and again for every new service, you will be just having one block which will have the Go template engine related inline injection done, and there will be a for loop here which will tell, okay, I'll go ahead with compute.google API, cloud platform.google API, service network.google API, whatever is there supplied in xr.yaml, which can be an array. Okay, so you can have that kind of a thing. So naming conventions are pretty important. How these resources should be getting created, and they should not be conflicting with the Kubernetes naming convention of 63 characters, etc., is something that we need to really be mindful of. And it also gives you velocity when you come to the platform options. The other thing is kubectl get managed is a command which can list all the resources that are getting managed by Crossplane. This particular command is firing a lot of Kubernetes APIs, so that's where it is often slow. You could see if you have a very big estate of Crossplane, you would end up having some timeouts also getting issued, and hence the command that I triggered for the Crossplane beta trace is something that you should be referencing so that you can have quick inspection done for the resources that are bound to a specific composition. When we are creating composition, we essentially have manage resource related template only defined, but actual managed resources get deployed only once we deploy the XRs or the claims. The other thing is that when we are talking about claims, these are beneficial if we have to deploy multi-tenancy aspect. Again, I have talked about that. RBAC is also something that holds true for the same. And then if we are deleting any custom resources, or if we are deleting any XCs, which are claims, the respective managed resources also get deleted or deprovisioned, right? So this is where the life cycle itself is tied to the parent object. So there is a parent-child relationship. But for some people who are interested in knowing whether there is a smooth path for you to have migration done from Terraform to Crossplane, yes, there is an orphaning related management policy which can be added as an annotation in the object of the resource itself. So here in your composition reference, you can have you can have an annotation added, or you can inject that specifically by doing a patching or transformation operation, and you can tell that you want to have Crossplane kind of either be orphaned from a controller perspective so that you can shift your resources to the other Crossplane resource, cluster, or what you can do is you can have a Terraform resource. You need to match the exact name and ID or URI that is there for that resource in the cloud provider in the actual name and upstream reference. Again, that needs to be done via annotation. So there are annotations available through which you can manage that. Okay, my upstream resource should be available in this name. If at all I am able to find that resource, have that particular resource now mapped to Crossplane. So it's where Terraform doesn't allow you importing of resources in seamless manner, but Crossplane can allow you mapping of resources that are already deployed by just referencing their URIs in an annotation. Again, we are not showing that in the demo here, but you can reference that in the public documentation. There is a good guide available for Crossplane related migration. The other thing is, if any one of you notice that in the XRD that we have some versions getting maintained. So this is the version that you generally see in the API version specification for your pods, deployments, etc. So this is helpful in maintaining the contracts, because we can tell that this particular resource is currently in alpha, but tomorrow we can have some enhancement introduced which can be labeled as beta, and then ultimately we can graduate them to production. So it can take couple of months time for you to promote from alpha to production. But then versioning is something for the API contracts, which are essentially open API specifications in the background, managed effectively via these versioning techniques. And you can have in XRD, in the same XRD YAML, just to make sure that you are not introducing any backward incompatibility or contract breakage, you can have multiple versions of open API specification managed here. So you can have V1 alpha 1 along with V1 beta 1. Let's say you can introduce a V1 beta 1 here, and then you can say V1 beta 1 is something which we are servicing and it should be referenceable. And then you can have serviceable set to false here, so that you tell that, okay, it could be referenced for any of the objects which are currently getting referenced, but it should not be served for the new objects. People who are creating new resources should be going with API version as V1 beta 1. Okay. So such kind of multiple versioning modules also can be maintained. And then the other thing, if you notice, just I have leveraged required. You can even have default set in the respective properties. So under name, I can have a default name and other things, etc. Okay. So just coming to the very last key takeaway related stuff. Crossplane is a Kubernetes extension. It's not a Kubernetes replacement. It is going to augment your Kubernetes platform rather than having any replacement. It is there for platform abstractions, and you can have multi-provider related kind of things leveraged. You can build your own APIs in form of XRDs, etc. And there is no vendor lock-in. You can keep the XRD very much the same, but change the composition it is referencing, right? So that way you can have the contract management changed. If at all you are moving from, let's say, AWS to GCP or one provider to another, it's just a change in the composition, but the underlying XRD can remain the same if at all there is an apples to apples service available in the other provider. Then there is a self-service, because we are just able to have the developers reference this without knowing who has created what in composition. Your platform team will be deploying composition and the XRD for you. So you just have to go ahead and supply the xr.yaml based on self-service fashion. The other thing is we are able to have the compliance related stuff dealt with in an effective manner. The other thing is it's very much baked or a fit for the CNCF landscape. You can have Velero for backup restore volume snapshots. You can have Kyverno for any kind of validations or policies you want to supply. You can even have OPA getting used. You can have Argo CD along with Crossplane to be able to have GitOps for Crossplane. You can Helm for further wrapping up Crossplane in a layer wherein you can have a Helm chart for your Crossplane deployments for infrastructure. So all these things are possible. Drift detection, we have already talked about. Import of resources is something we have already talked about. Kubernetes events, we saw. Metrics is something you can expose via Prometheus. So with this, you should have understood, at least this particular talk was focused on giving you exposure of what is the art of possible. Again, we have not really covered the actual benefits from a complex implementation perspective. This was a very bare minimum vanilla related setup. And this is where the session doesn't end. Okay. Crossplane is something which can extend Terraform by using a provider of Terraform. So provider There is a Terraform provider like GCP provider for Crossplane available, wherein for the resources which are not available today from a provider perspective, but for which the provider exists in Terraform, you can leverage Terraform provider by creating something called as Terraform workspaces, which is different than the Terraform workspace concept that you have in Terraform Cloud or Terraform CLI. Or there is an object provider wherein you can reference a bunch of Terraform resources, and you can have the Crossplane related XRDs and compositions created automatically via a tool which Crossplane provides. That's called the Upjet provider pattern or the TerraJet provider pattern. The new name is Upjet. You can even have Terraform rely on Crossplane. So essentially, I'm hinting towards them coexisting also in some remote state, wherein you can have Kubernetes manifest, official Kubernetes provider Kubernetes manifest with the custom resource definition that you have for your for your Crossplane, or you can have null provisioners or local exec blocks, etc., to trigger any Crossplane related operations for Terraform. Again, when you use this or why you use this from for Terraform to be invoking Crossplane is something which is in question. But Crossplane certainly can extend Terraform for many of use cases because providers are still more rich in Terraform than Crossplane. So that's where we get to the very last section, which is we have seen the happy path, we have seen what Crossplane is providing us with, but let's see some of the demerits of Crossplane. Documentation is limited, community is developing, though it is CNCF incubating, still it's kind of not as rich as Terraform from community support perspective. You require deep knowledge of Kubernetes. That's the first thing. Whereas with Terraform, you just require HCL language to be learned. You can only run Crossplane on Kubernetes, but how that Kubernetes cluster comes, as of now, we were using Minikube. You could have used Kind, but that was just for local demonstration. If you have to really go in production, you would need a Terraform module or probably some Kubernetes cluster to be kind of created via Terraform or any other utility, or directly using the console to be able to host Crossplane. Then you can fall back to Terraform, as we saw. There is no Terraform like plan available today. You can do function schema rendering though, and you can have some kubectl dry runs, but there is no plan related stuff. So you really depend on the Kubernetes API to interact with the Crossplane controllers, and controllers then interacting with the providers to be able to get the status. So there is no plan, unfortunately. There is a Crossplane V2 version which is going to be soon released. It's already in preview. There were talks of having some sort of planning related functionality introduced there, but I'm really not sure because the release notes, at least in preview, don't show them. Then if there are any complex requirements, you might need to go ahead and instead resort on writing composition functions which leverage KCL, Python, Golang, or some sort of language. And then ultimately you saw that we were using xpkg.upbound.io, or you could have some private registries where you want to maintain the function packages and the provider packages. So this is where you additionally have to have an artifact registry maintained, unlike what you have in Terraform. So that's where I'm up for questions, and these are my coordinates. In case you want to spread news about this particular talk, feel free to have these hashtags used. This is the QR code which you can scan, and you can connect with me on Twitter and LinkedIn. Thanks again for listening to me, and thanks for staying 10 minutes more on top of the hour. And also, I'm up for questions if you have any. I know there were a bunch of questions that you had in the QA section. So if you want to ask some specific questions, I'm happy to help you.
Thank you so much, Anmol, for this brilliant and thoughtful provoking sessions. Your insights on managing infrastructure as data using Crossplane truly showcase the future of modern platform engineering. Not only this, what made the session even more special was how attendees got the chance to not just learn about, but also gain practical exposure on these modern infrastructure approaches. Thank you, sir. Thank you, Anmol, sir, for giving your time to CNCG Gurugram. If anyone has any questions, you can drop down your questions in the chat box. Rakin Vikark has some question.
Yeah, please. Okay, can Crossplane, I'll just read out loud. Can Crossplane integrate with an existing pipeline tool like GitLab or Jenkins to automate infrastructure provisioning as part of the application deployment process? Certainly, Rakin. So basically, Crossplane, as you would have understood by now, is just like any other Kubernetes manifest that you are exposing. So like you have CI/CD pipelines created for any of the Kubernetes artifacts like deployments, config map, etc., you very much can have the pipeline set up for Crossplane specific manifests. So instead of referencing the pod or deployment, it would be referencing the composition. And ultimately, you can have Crossplane beta trace, rendering, deployment commands, kubectl apply commands behind the scenes orchestrated via any of the steps that are there in GitLab or Jenkins. Hope I answered your question. Okay. There was another question by Monica. What does managing infrastructure as data mean in practical terms, and how does it differ from infrastructure as code? So specifically, infrastructure as data is coming as a theme here because of Kubernetes, we are able to have the actual declarative state maintained. We are able to supply that in form of YAML or JSON file, and more importantly, we are able to have the state managed for the reconciliation ultimately in etcd. So that's where we are able to have all the reconciliation logic work. Even if your Kubernetes cluster goes down, the next time it comes and it recovers from the etcd snapshot, it is able to resume from that point itself, and it is able to start reconciling the resources that are there on the cloud provider. So that is where infrastructure is actually getting now transactioned in form of data, wherein you have a proper data store actually taking care of your infrastructure thing, and you are having reconciliation basis, the status, condition, etc., which are getting reported in your Kubernetes control plane. Hope I answered your question. Okay, any other questions? If you don't have any questions, then I think I'll give it back to Ali for concluding the session. Yeah.
Thank you, Anmol. I would like to thank each of the attendees who joined today, especially Tapas sir and Anmol sir. A huge round of applause virtually to our incredible CNCG team. And up till then, let's keep learning, keep building, and keep showing up for the community. We will be back super soon. As mentioned, next event is tentatively on 7th June. So, expecting you guys to be there. And for the giveaway part, you can the most active and interactive attendee today was Narendra Vish, if I'm not wrong. Can connect to the organizers or anyone from the team. With that, signing off for today. I hope you must have learned something. So thank you once again, everyone. Bye.